Hello learners, welcome back to the C programming lecture series. Hi, Kirti Sharma. I'm working as an assistant professor in St. Andrews Institute of Technology and Management, Gurugram. Today in this lecture series, we will discuss about function calls, or you can say parameter passing techniques. It's most important topic from your university exam point of view, so mark it. Okay, so under which we will discuss two techniques, call by value and call by reference, and next we will discuss the recursion in the C. So up to now we have already discussed the basics of the function, introduction to the functions, what is parameter, argument, and actual parameter, formal parameters. We have already discussed these terminologies already in our previous lecture. So now in this lecture we are starting with the parameter passing techniques. So first we have the call by value and call by reference. There are two parameter passing techniques. So there are the two ways in which what it's mean actually parameter passing techniques. There are the two ways to pass value or data to a function. You have to pass the value or data to a function. In two ways you can pass it. First one, by with the help of by calling the value itself, or by calling the reference of that particular parameter. So how we will perform it, we will see this one by one. So first, original value is not modified. Original value is not modified in call by value. First point to note, in call by value, original value will remain as it is. It will not modify. But in the call by reference, every change will be done in the original value itself. Okay, that is the major difference in between them. Okay, so what about it? Original value, whatever is the original value of the parameter we are passing, and if it is modified, then you have to refer the call by reference technique, and if it is not modified, then we are using the call by value. So when to use call by value? When we are using the call by reference, you can eliminate them, right? So let's start with the call by value. So call by value method, in the call by value method, the value of the actual parameters, I hope you all are aware about the actual parameters. Actual parameters are the parameters which you are calling um, within the main body during the call, while you are calling the function in the main function. So within the main body, when you are calling the function, any function with some parameters, then those parameters are known as actual parameters, right? And what about the formal parameters? The parameters that you are giving at the time of definition of the function. Either you are defining the function outside the main or inside. It's up to the, like, wherever you want to define a function you can, but during the definition of the function, whatever the parameter you are using, it's known as formal parameters. Okay, so I hope it is clear. So a call by value, what it will do in call by value method, the value of actual parameters, whatever you will pass in the main body function, uh, whatever you will pass as an actual parameter, as it is, it will copied into the formal parameters. That is the theme of this topic. Okay, then we can say the value of the variable is used in the function call. In call by value method, we will use as it is, right? So in call by value, we cannot modify the value of the actual parameter by formal parameter. So we cannot modify it, the value of the actual parameters by the formal parameters, but whatever is the value of the actual parameter, it will be copied into them, right? So in call by value, different memory is allocated. There will be the different memories for the actual parameters and formal parameters. We are not doing the changes at the same common memory place. No, there are separate memory space available for actual parameters and formal parameters, right? So but just we have to copy the value at the two different locations. One location will be of the actual parameter and another location will be of formal parameter. So we will see these things with the help of example. So in the actual parameter is the argument. I have already told you what is the argument. We have already discussed like difference between argument and a parameter. The actual parameter is also known as argument, which is used in function call, whereas formal parameter is the argument which is the used in the function definition. I have already told you this thing, right? So next we have an example. With the help of example we will see these things, right? So we have already mentioned these points, like there will be different locally stored. It will be the parameters in the location memory. There will be the different location memories for the actual parameters and formal parameters. So function parameter, it is changed for the current function only. It will not change for, permanently. It changed for the temporarily. This is a change for the temporarily for the current function only. So when you are calling, when you will call the same function with a different values or different actual parameters, it will give different result. So it will its change is not permanent, it's temporarily change. Okay, so next is the example to understand the call by value in a better manner. So first we are taking here defining the function name is change, right? So void change, data type is void. We are taking this is a formal parameter that we are giving here as at the time of definition. Num is a variable here which we are passing here as a formal parameter. So here this function is printing the before adding values inside the function num. What the value of the function num, it will print as it is over here. Okay, so what it's mean, here we are doing the num, we are taking the num and we are adding the 100 into the num and again storing it into the back to the num. Also you can write, we have already studied in the operator num plus equals to 100. Both are the same things, right? So printf, after adding the value inside the function num, what it will be, it will print over here after addition and before addition 100, right? That was the definition of the function change. Change is the name of the function. Now we are starting the main here. Here I am taking the local variable x, whose value is, which value is 100. So in memory location, we have assigned a value 100, right? Before function call, x is equals to, you have to print, it will print as it is what? Value x 100, it will print. Now calling of the change function, this is called as function calling. So here we have called the function with the name of the function, that is change. We have passed a parameter here. Which kind of parameter? Actual parameter is here. That's why we are passing by value. What is the value of x? That is 100. We are passing the value of x as 100 to the change function. Now what will be there? Now this num variable value will be copied as, it was blank up to now. Now the copy of x value will come over here. Now its value automatically become 100. The location of both the variables are different, though both the parameters are different in the memory, but the same value whatever was there, it will be copied over here, right? So now it will come under this body of the function. It will print before adding value inside function num. What it will be, it will print 100, right? Next it will come here, num value is 100, 100 plus 100 is 200, num value will have 200. So it will print after adding value inside function num 200. So what is the theme of this? Like again it will come back after the execution of the main function. Next is printf after function call. What is the value of x? That is the main thing to focus over here. The x value will not update, it will remain 100 only. The change where it is changed, before the addition value of num was 100. Now it is updated with 200 because we have added the num value with 10 over 100. So now now it becomes as 200. So value of num is updated, but value of x is not updated. It will remain as it is. That's why after calling the function, if we are coming back over here and printing the, like after function call, what will be the value of x? It will remain 100 only. So what will be the output? First we have printed here this one. Just wait. We have printed here. What we have printed here? Just wait. Yes. We have printed here this in this line before function call, this one line as 100. This is printed. Now function call is there. Yes. Now what it will print? It will print this value, this particular. It will print over here this particular, before adding value inside function num, it will print 100 value. Yes, it will print 100 value. Now this one line is completed. Now what is the next? After adding value inside the function num, what it will be? Like this one, this line, it will print 200. So 200 will print here. Next is after function call, if it is coming back over here, after function call, what is the value of x? It will become 100 itself. So there is no any change in it. So it was all about the call by value. So I hope it is clear. Next is like here, not one thing only, in formal argument and actual argument, right? So num is the formal and x is the actual. Whatever is written in the x, it is as it is copied into the num, right? So different copies are there. Now you are updating this formal parameters only. You cannot change the actual parameter. Let's take an example. If you are at your home, you will react whatever you are, your basic nature. So you will not do the formality inside your home. But if you are going outside of your house, so outside your home, then you will behave some formal kind of activities. Like if you are meeting with your friend, your relative, you are going into your relative home, so you will behave some formal manner. So you will think before behave before act anything, do anything, right? So same thing in the actual parameters and formal. So actual is the inside the main body, that is your home, right? You will behave actual whatever you are, that is remain as it is. If you are coming back to your home after some time, after few days, you will be as it is whatever you was actually. You will not behave formally in your own home also, no, because it's your own home. By default your basic nature will come into the existence when you will be there in your home. You will not do the formality at your own home. If you are going outside, then only you are behaving as a formal, right? So same thing here. If you are in actual, whatever is the how many time whatever is the timing you are spending with the formal argument or formal parameters, it is okay. Every change will be there. Formality is change outside of the home, and always do the change in the formal communication only. But when you will come back to your home, you will behave as it is, as you was, as your basic nature. That is the best example to give you the clarity about this topic. Okay, so call by value. Next is call by reference. So I hope it is clear already. Or call by value, it's just a thing like value of the formal parameters that we will focus. Value of the actual parameters and formal parameters. Whatever will be the value of actual parameters, it will copied as it is to the formal parameters, and whatever the changes will be takes place, that will takes place only in the formal parameters. When it will come back, when your compiler after executing the function, performing the operations on the formal parameters, whenever it will come back to your main, then it will behave as it is as before, right? There will not be any changes, right? So it was all about the call by value. Next is call by reference. So call by reference, in original value is modified, you pass the reference. So here we are talking about the address. Address means reference. We are referring some address to go somewhere. Getting this point? Just consider this as an example. You are referring some address to go somewhere. In call by value, you are giving the value as it is. Here you are giving the reference or address to go somewhere, right? So address of the value you are passing here in the function. So actual and formal parameters shares the same address now, because we are sharing the address now. We are not sharing the value. We are not copying the value. Now we are giving the reference or address. Address cannot be cannot be have the copied, because in memory address, one address given to the one location only. You cannot use a copy of the address, right? So variables can share the address, but they cannot be copied, right? So value changed inside the function will reflect the change into outside of the function also in call by reference. That is the main thing to understand. So to understand the call by reference, you must have basic knowledge of the pointer. So I'm just introducing here a new concept of pointers here. We will discuss this topic later on in depth. Now only I'm giving you the basic knowledge for the pointer. What is a pointer actually? Pointer is defined as a variable like that points to the value of the at that address, and it is represented by asterisk symbol. If a is any variable, in front of a I have put that asterisk symbol. That means this a is a variable of pointer data type. So I have already mentioned you in the data type like primary data type, basic data type, that was then derived data types, and we have already discussed in the derived data types there are some data structures are available that we will do separately. Pointer is also one of them. So here a is a pointer variable which has the address like value at that address. Whatever is the address of a, like let's assume 1000 h, this is the address of the a well a variable. So whatever is the value here like 10, it will give you the value at that particular address. By reading the by tracing the address, it will be able to give you the value at that particular address. So it's the main concept or main point to note about the pointers. So let's use we will see the use of pointers in the call by reference. So this is an example to get better clarity about the call by reference. So here this same symbol is used again like pointer symbol with asterisk. Num is a variable here. So which type of parameter we are taking over here? This parameter is of like we are giving a definition. This is a formal parameter. Num is the formal parameter. And which type of parameter? Pointer data type. So here we are giving the same definition. Same program is actually I have taken the same program to give you the clarity here. Like there should not be any kind of confusion in between call by value and call by reference. That's why I'm taking this same example here also. Okay, so here same I'm adding the 100 into the num variable that is of pointer data type, right? So always compiler starts from the main. Now this time when it will start from the main, x value will be is 100. So memory x location value is 100, right? So next is before function call, it will print what? 100. Before function call x value, it will print 100. Now function call is there. Change function call. Whenever this line is triggered, it will go to the function here. Now after coming here, after this line, our compiler come here and it will execute this thing. Num, it will create the variable num location memory space. Then what will be the size of it? Integer type. So in size will remain like it depends on the like your system hardware. It will can be of 2 byte or 4 byte. If you are using 32-bit, it will be of 2 byte. I'm assuming it as a 2 byte. Okay, so we have seen that this variable is of pointer data type. So it will take the reference address here. So what is passed over here? The end percent symbol here in front of any variable. This is indicating the address of the x. I have already told you, if you are using end percent in front of any variable, it will behave with a single variable you are using. It will behave like it will give you the address of x. Whatever is the address of the x variable, it will send that. It will send that, right? So what is there? Here is the address of the, like let's assume 2000 address of the x. So it will send here 2000 as a address. Okay, so I'm just removing it, address. Okay, now it will come here. Before adding value inside the function num, it will print the value. So same address is shared by x as well as num. Both are pointing out the same memory location, right? It is possible to share the same memory location, yes. So what it will be, show the value of num, it will also show 100. Now see the beauty here. If you are doing any change in the formal parameter, like you are adding 100, where at the address of the num, this will become 200. Now we are doing the change in the num, the informal parameter, but by default it is also changing the value of the actual parameter. So that's the main logic in call by reference. Here we are sharing the address of the variables, either it could be your formal or actual parameters. So in call by value, formal and actual parameters having the different memory location space, different memory space, and in call by reference, formal and actual parameters having the same memories will share the same memory space directly or indirectly. Okay, so after printing this, it will print 200 over here. Now it will come back here in this line, so it will print after function call what is the value of x. Now this time it will not print the 100, so because of what, already x value is updated here with 200. It is done by num, but it is by default accepted by x, so that means it will come here 200. It's like an example, like you can say, if you are living in a family, like two members are there in the family, and you are sharing a home, right? If one member of the family do any change in the home, it will remain same for the, this change will be also applied on the second member of the family also. So you can take it an example as like this. So I hope it is clear to all. So it was all about the call by reference. So this one is the output that we have already discussed, like both are sharing the same memory location. First it will print x value is 100. After going into the memory space, like into the num will print same 100 because they are sharing the memory space. Then after change is done by the num, by adding the 100, it will become 200. Now this change will become permanent now, right, for the x also. So permanent means here, doesn't mean whenever you will call the function, this function it will remain same. No, this change I'm saying, like num has done the changes, it will remain same for the x also. So because they have the same memory address. So this was all about the call by value and call by reference. I hope both the concepts are much better, having clarity. Now this is the end of your end of this lecture. So up to now I thought like every doubt must be cleared, should be cleared. If still you have any doubt, then you can put the question. Then in next lecture we will discuss the recursion in C, and we will discuss the formatted and unformatted input output functions. In here there is a difference between the call by value and call by reference. So these are some differences that we have already discussed, like copy passed here address passed, here change is not reflected in the other functions, here it will reflect. Here the memory location will not be in shared mode, it will be in the shared mode. Here memory locations are needed, here less memory location needed, here more memory location needed. Why? Because both the parameters having the different memory space. Here same they are sharing the memory location space, that's why less memory. So these are some differences that you can take as a note in between call by value and call by reference. This topic is most important from university exam point of view. It may possible directly come as a topic, or it may come as a differentiation between these two. Okay, so you have to give the examples also in order to distinguish them. So I hope it is clear to all. So stay tuned with the lecture series. Thank you, have a nice day.